Really simple D3 visualization, but I was working on this earlier. So all it does, okay, it takes a BART map, puts it in a SVG, and then the whole thing, all it does is it plots this time. But this time comes from the BART API. So now actually we'll show the exciting part, which is the code. And we go into WebStorm. Can we see that? Okay, so I'll go up to the top. So okay, actually, this is like the key line right here. Create BART map. So it goes down here, and there's a function that will. These are the x and y, how big the map's going to be, and then it does a call to the BART API, and it gets the whole list of all the stations. And it does what they help me with is this function right here, which is to get station by name in Embarcadero, and that's the exciting part of this code, is because they help me with that. And get station by name. It's that easy. It's a data.filter. So that's the point of this. Their session was they're trying to show you how to filter data. So it just checks the if the key.name is equal to name. Can you take a picture of me? And if it's still on. And then it will return true. So so it calls get next time with Embarcadero, and then it calls plot Embarcadero time, which is this little thing here, which is it does an insert here. It takes insert the text, puts it at that position, and gives it the value next time. That's it. That's the whole thing. Let's look at it again and see if the time updated. Yep, 7 minutes. The next train to Embarcadero is 7 minutes. Thank you.
This is what I wanted to show you. I just posted this blog about a visualization I made. So it's on LinkedIn. And that's what it looks like. So this is unfortunately not D3, or maybe not unfortunately, who knows. Either way, it's either a visualization of an algorithm for computing pH or a game, depending on how you want to look at it. So take your pick. From the game standpoint, your goal is to achieve a ratio of 10 water molecules for every single hydronium ion, also known as H3O+. By clicking on the moving spheres, circles, what have you. 2 spheres, how about that? Now everyone's happy. You can actually change them from one state to the other. And this tries to teach the player the concept that by adding hydroniums, you lower the pH. So you can watch the pH go down as you add hydroniums and watch it go up as you remove them. This may seem like a trivial concept, but for anyone who's tried to teach chemistry, it's actually pretty tough to get this point across. So I thought a visualization might help. And then we're only 1 click away. Woo! All right. Thank you, thank you, thank you. And then the code is on GitHub. So shameless plug for a new visualization engine I'm working on that's also open source called VisFlow. That's what I used to make this. It's still very much a work in progress. But all the code is pretty much in this one JavaScript file. Let's see here. So there's no D3. Like I said, all the engine stuff is at the bottom. I tried to make the engine like as minimal as possible. So all it does is the in-game design visualizations are rendered using a loop. So you have a global loop that just runs your request animation frame, 60 frames per second, and you basically have to get everything done within that loop, and it happens in a sequential order, so you maintain the asynchronous flow control using ECMAScript 6 promises. And yeah, that's pretty much it. Thanks, guys.
Okay, so I hope you guys can all see my Dilbert tie. So I'm here to pitch a data source. So it happens a nested data source to all people who want to do visualizations. I've been working on a service called USPTO.io, which shows what patents, who owned what patents when. And it's a rich data source of easily available JSON, structured nested JSON, which to database people should be an awesome thing. So this is what it looks like. So I put in a really gimpy UI on it because I'm not good at visualization. But so we can search for, you know, data interactive. So here we get your patent, Vadim. This is obviously not fun looking up single patents. What's really fun is you know, getting larger data sets. So we just look at everybody who owns patents related to data interactive right now. And we get a whole bunch of more stuff that's interesting. But the really interesting thing to me is that you can go and look at the actual API calls. And this is the data that I get back. This is the actual JSON. So that's very sort of eminently graphable, visualizable. And you can easily bucket this. So say right now it just shows all the data for today. I can make it into a date range. So say 2005 to 15, and then I can tell it to do it by year. And I'll get a bunch of data if you start minimizing the JSON. You can see 2005 to 2006, 2006 to 2007, blah, blah, blah. If I change the aggregation that I'm looking at, so say to unique patents, it will just show me year after year how many unique patents there were in this particular, that match the criteria. So you can see that this is the number that I'm looking at, unique patents, and this is the given date range. And there's plenty of these aggregations that I can draw on. This is obviously very nice for a graph because it goes like this, right? Which is always nice with a graph. But so that's it. All the queries are just in the URL string, so very easy to use. And I'm looking for people who want to use it. This is my pet project, so anybody who wants to collaborate and do some cool things with it, please get in touch with me. Thank you.
All right. So this is a bunch of D3 blocks examples. I've scraped and pulled together from all corners of the internet 5,000 blocks that have been made. I'm using cross-filter here so that you can filter down by different API calls. Check them out. The fisheye plugin, all the code is down here somewhere. And then this is sort of like a grid layout. So I tried to make a grid layout, and I ended up making a brick wall. But this is the same blocks, but you can filter by people. So got mine. Who wants to guess what Mike's looks like? Mike Bostock. Boom. You can see you got things started down here. But this is pretty encouraging. A lot of people have been making blocks. And I got to plug the project I've been working on, which is building blocks, which will help you make blocks. It's blockbuilder.org. It's got a little intro here now. It's essentially kind of like a special JS fiddle for D3. It comes pre-packaged with some boilerplate code you can use with the margin convention. This resolution is kind of small, so it's going to be hard to code here, but I can make the width of a rectangle. It changed some code, and it updates your visualization in real time, so you can kind of get an interactive sense for coding your D3. When you save it, it saves to a block. So you can also get a browser not plugin, bookmarklet. That will, if you're on any block, you'll open it in Block Builder, and then from there you can fork it, change it, or edit your own things. Finally, one thing I really want to drill into people's head is to add thumbnails. So in this UI, it looks kind of weird. But you can just quickly choose any screenshot that you make of your visualization, and it will pop it into here. And when you click, well, let me demonstrate. This isn't the right screenshot. But if I were to click Save this thumbnail, it would save to the gist, which used to be a really painful process with the command line and all that stuff. So in this visualization, all the black squares are blocks without thumbnails, and all the green squares are blocks with thumbnails. So we're doing pretty good, but we're not there yet. And I'd like to have this one, which is, again, the same data set, but with only the ones that have thumbnails. It's just a massive amount of, it takes a while to even just load all these images. But all these squares are blocks that will eventually fill in. So if you want to just peruse what people have done with D3, but always end up with a block, this is a good place to go. So I hope to see yours in here. All right, thank you.